All right, update time. There's our, I don't know if I'd call it a faux beam. It's not necessary, but it does give us 2 points to bring our pendant lights in. We laid out, we found the ridge center line here, and we found this grid. I made sure that this flooring was installed normal, which is to say perpendicular, parallel to the actual floor box of this structure, which it is. So it was actually easy to find this dark, this is like a selection of PP colors here, but this particular stripe heads right over and dives right into the center of this rafter system, so we can be sure. And there's our little beam section that we made. That's the center of him, and this is the center of the house right underneath the ridge. Anyway, so we've got that location on the floor, but I was able to check my drawing and check my clearances for the refrigerator and roundabout where the pill-shaped island is going to be. And then I kind of wanted those pendant lights to be in the center of the circle that creates the arc on either end of the island. Close enough to never know that it's not by eye. So we're not going to be pedantic. We got real close to that, and that's good enough. So I'll take you upstairs. It's like, woo, ship ladder here. So what we did here was I just grabbed this rafter with a big quick grip clamp, kind of close. I use these for reference. I knew how long, this is a rhombus, or excuse me, this is a trapezoid. When you're making pieces on a job site and somebody asks you for a component with angles on it, you have the choice to have a trapezoid piece or a rhombus where both angles are heading in the same direction. So we've got a trapezoidal piece here. Anyway, I knew the short to short as opposed to the long to long. I knew the short to short was 60 inches, so I threw the tape in here prior to even bringing this up here, and I found 60 to be close to this body line and that body line in the homosode. So I knew roundabout where this guy was going to live, and so I was able to grab this with one quick grip. This guy doesn't weigh that much. I'm standing here. I had the ladder there too, but I just went out here. I had to pack in a block to hold the two sides of this open enough to be sure to slip easily and not fight going around that rafter, because of course this goes on the side of it. Anyway, so I had that level taped on it, a block jammed in it, so that I could reach out there and just go shoop right over top of my one clamp, and then I could rely on that end not giving way because the clamp, and then I'd place another clamp here, and then it would sit there. And I could take this end up and reposition the clamp, and this end up and reposition the clamp, and up with a dead blow hammer, and rock him all around until my level looked good. And then I just shot a couple nails in there. And then once the nails were holding it, I came back and stuck. You probably can't see these; it may not expose, but they're Timberlock lag replacements. They just have a decorative, kind of large head, black circular thing, and they give you a similar aesthetic to the bolts, the carriage bolts that are downstairs. We're not going to be reinstalling those. Most of them were bent when they came out, etc., etc. But there's a pair here and a pair here and a pair on both ends on the other side. So you could hang on this thing a la, is that Jurassic Park 2? Or, yeah, it's 2. Where the gymnast girl does the old kick the Velociraptor. Anyway, you could go out here, or you could put your porno mags or whatever down in the cavity here so that nobody knows. But anyway, it's in here. Oh, and we got our light fixture boxes, and they'll be easily wired up. We're going to have to do a little sneaky, probably on the other side of this rafter with some conduit, so that up here you don't see any systems. We don't have a wall bay to hide any electrical service, but it's just a lamp, 2 lamps up here in series or daisy chain. So we'll go on the other side of this rafter, and then we'll go over and right down into the wall to disappear, and you only appreciate the little bit of conduit if you look up there and are really trying to see it in the future. So that's the best that we can do. So those are there. And we're 4.5 minutes into our video. So now we're going to pivot to the washing machine. It wouldn't be a technically magic project unless we made an error that we're going to remediate. I don't know what I was thinking. I was going to do all of this underneath the building. I don't know what I was smoking at the time. I was going to go straight on through and do all of this there, which the lower you begin forces, because you must travel downhill 1/4 of an inch down per foot that you travel, it just carries your whole system, depending on how long your system is, down further and further and further. So you want to start higher up for that reason, and you can I get to all of this right here, no problem. So anyway, I changed my thinking, and so our trap is here, and our 2-inch line, which is what code stipulates for washer drain, heads in that direction. And this box that you buy has multiple choices for arrangements if your water comes in from above or left, right, wherever you want to. So you just flag with the included flags which knockout is the actual connection, because this will actually be finished with drywall before you finally knock that out in most cases. Since we're doing everything on this job, we could knock it out right now and no one would be the wiser. I did get a drainable P-trap. It's too bad because you get 2 choices as far as I can tell. You get a P-trap that has a union that you can undo. You can twist him off. You can separate that. Then you could take this big belly component and stack right out of here and clean out that trap if you needed to. On the other side of it, you could get a P-trap that has a drain that you could undo, ski here, and it'll pee out the gross, water and stuff that sits in there if you're trying to winterize or clean this out. But he socket welds, so you can't have one that has a threaded union and a drain, apparently. So this is a commitment of glue, and then your only option is to open this here. This hole, like I said, was an error. I may end up putting a little tail of garden hose down in there, and then putting a little, what would that be called? A grommet, basically, that finishes around that hole. But that'll let you, let's see, it would just lay there. I guess you'd have to unscrew this. Yeah, that wouldn't be worth doing. So anyway, you just have a little base in there if you wanted to drain, and we will fill that hole because we made that mistake. So this is the type of thing that you try to be too clever and you'll outthink yourself, so you want to be careful of that. So we come over here. Now, also, I was planning on putting in a air admittance valve as a vent. Over there, we went right up, existing hole out through this roof, and it has all of the necessary, I don't think I have it down here, but it's a big rubber boot that goes around that opening, and it has to be finished in underneath the shingles and everything else. So the fewer holes that you poke in your roof, the fewer potential leaks you have, and it's a lot less farting around. So you can get one of these guys, and there he is on the box there. He goes in and he can suck air, but if you try to pressurize the system for any reason, if there was a debacle, it would shut and you wouldn't be able to push water out. Some places they don't meet code, blah blah blah. So I was going to put him up there and call it vented, but instead I'm going to run over into this wall here, which will allow me to now drop down under the floor because of this. For the sake of this room, I don't have a wall here, and I can't go through the doorway, and I have no wall to keep going this way. So we're going to go down now, but now I'm in my opening in the floor where I can work, and we can tie in and go around the corner, head that way. You need to be, I think, 8 feet from the trap or less, 8 feet away with your vent on 2-inch drain pipe. And to tie into this vent over here, we wouldn't quite make it, unfortunately. So that's why I put my sanitary tee here. So down will go the water, and up will go a vent. We're going to have to turn because of the window, and go over, turn again, and go up. And we'll go right through over here, just like that. But we'll go straight out the roof, and we will need another vent penetration there. There's just no other way to slice that. So I was going to touch on the difference between a sanitary tee and a Y. Let me see if I can find. Here's a Y. So Y is designed to be used in this orientation. When material fluid is traveling in the direction of this leg, this way or that way horizontally, and you're dropping in another system with fluid, you want to come in at a hard angle like that to absolutely, definitely continue to move at that in that direction, as opposed to a sanitary tee, which I wasn't prepared here. My apologies. Looks very similar, but you may not, according to code, use it in that same orientation. You would think that it would also send material in that direction, but it has to do with the exact angle and the exact cavity geometry. This can hammer straight down, boom, into here, too directly, it doesn't come in well enough. So that you use in this orientation. When you have a vertical stack system and you're coming along with fall, 1/4 inch a foot, and you roll over the corner and you go down, that is designed to waterfall like that and allow air. And this may not be used in that application. This comes flying in too hot, and it obstructs. The fluid dynamics have been engineered in that way. So this guy lays on his back, Y, W-Y-E, or just the letter Y. And sanitary T is designed for use vertical. So he's what we chose here. We're going to waterfall down, and our atmosphere will be drawn from above to help us easily do that. So that's a little bit of that. And we'll come back and touch on the rest of this stuff.